Okay, welcome back to another session of Unit 8 notes. We are now moving into the last piece of the puzzle regarding right triangles. We've learned pretty much everything about right triangles we can regarding just sides. We know Pythagorean theorem, how to use it to solve for a missing side. We know a couple of special right triangles now that we can use to solve for missing sides if we don't have enough information to actually use the Pythagorean theorem. So the last piece of the puzzle is what gets us into the world of trigonometry. We're going to not be scared of it because it's a big word. Trigonometry literally just means to measure triangles. Trigo means triangles, metry means measure. So we're going to do one more measuring triangles piece of the puzzle. Now trigonometry is different from Pythagorean theorem in that you have to use angle measures and side measures together in the same equations, in the same formulas to solve for missing pieces of a triangle. You can solve for missing sides, you can solve for missing angles. If you know two pieces of information, if you know one side length and one acute angle measure, or if you know two side lengths, you can solve for all the other parts of the triangle. So it just gives us an extra tool in our arsenal. Before we actually dig into the notes, we're going to lay down our pencils and we're going to do a sort of a preview trip with my fancy schmancy graphing calculator. So I'm going to go just to a blank sheet of paper for a minute and pull out my calculator. Now, don't panic if you didn't check one of these out before you left. Remember, I did upload for you two things that are usable. One is instructions for how to download the free software for a calculator like this if you have a device that can hold it. That's one of your options. Some of you checked one out, which was fantastic, and some of you may be still using the online graphing calculator. It's actually a scientific calculator, that Desmos calculator that I provided a link to in your folders. And fortunately, that calculator is pretty friendly, and it will make things look exactly the same on its screen as this one here. So those skills should transfer pretty nicely. Okay, so the first thing I want to do is start with a triangle that I know. So I know a 30, 60, 90 triangle. So I'm going to draw a picture of a 30, 60, 90 triangle that I have memorized. Now, if you haven't memorized your triangle yet, you're a smidgen behind. You should know them by now. Guaranteed, they will be on standardized tests in your future, and you will just be expected to have those memorized. So I'm going to start with a right angle in the bottom left-hand corner, and put a 30-degree angle at the top and a 60-degree angle in the bottom right. And I know from my studies of section 8.2 that the short leg, which is opposite the 30-degree angle, is going to be 1. The hypotenuse, the longest side, is the longest side, 2. And then opposite the 60-degree angle is the middle-sized side, which is the square root of 3. Square root of 3 is about 1.732, so it's bigger than 1, smaller than 2. This triangle, I should just be able to pull out of my head at any moment, write it down on a piece of paper. Now, I'm going to do a new trick with this triangle today, because it'll go along with understanding what the magic buttons on the calculator do. So, first thing I'm going to do is just take a look at my calculator. I have on this calculator a trig button. So it's right beside the 7. To the left of the 7 is trig, which is short for trigonometry. If you're using the online calculator, the Desmos calculator, you will actually have the trig functions there on the main screen. So let me show you what this looks like. When I click on trig, I get a menu with 12 different functions on it, 12 different keys that I can use. The only ones that will be on the online calculator that I've uploaded are the first 3 in the top row, SIN, COS, and TAN. And those are functions. They actually do a job. If I put one of those 3-letter abbreviations in my calculator and then tell it a number, it's going to do something with it. So they work like square root functions. They work like addition, subtraction. They take numbers and do something to them. So the first goal is to figure out what exactly the calculator does with these functions. And I got a little carried away and clicked on something I shouldn't there. So trig. I'm going to check out this first one. It's SIN. Now it looks like the word sin, but that's just an abbreviation. The actual spelling of the word is sine, S-I-N-E, and we just use the first three letters as an abbreviation when we write it mathematically. So I'm going to call it the sine function because it's not really the sin function. Now, when I press sine, it's going to give me a set of parentheses. It wants an input. It wants me to give it a number. Now notice that at the top of my calculator, right now I am in degree mode. There's a little DEG up there. If for some reason you are not in degree mode, it will not give you the right answer. So I'm going to run through very quickly how to fix that if it doesn't say DEG on your screen. If you have the online version, it's automatically in degree mode. So the Desmos calculator is. So if I go to the home button on and settings, number 5, and number 2 is document settings. The second cell is the angle, and by default the angle is typically set to radians. So if you have a brand new calculator, or if you downloaded the online version or downloaded the software for this calculator, the default setting is going to be radians, and you'll need to change that. So if I go to that cell and click to the right, I'll notice that I have 3 options: radian, degree, and gradient, and I want the degrees. I don't even need to know anything about the other 2 at this point in time. We don't use radians until we get into heavy-duty trigonometry, usually in pre-calculus. For now, degrees are all we're ever going to use. So we're going to choose degree, and then we're going to go to the bottom of the screen and we're going to click on Make Default. I want this to be my new default setting. If I just click on OK, it'll change that setting for this current document. But if I open up a new document, it's going to revert back to the old radian setting, and I don't want that to happen. So I'm going to make this my new default, and if I make default, then it's going to apply these settings to the current open document and save them as the default for new documents. That's what I want. So click on OK, and it takes me back to my home screen. I'm going to press 4 for current and go back to the current document that I have open. And now I'm in degree mode. Notice that I'm in documents, not Scratchpad. Scratchpad has a separate set of settings, and I really want to stay away from there. Okay, so I have sine open parentheses. I'm going to put in one of these acute angles. You're only for this class ever going to use an acute angle, so something smaller than 90. So I'm going to put in a 30 and press enter. Now, the online version of the scientific calculator is probably going to give you a 0.5. It'll give you a decimal equivalent instead of a 1/2. Of course, we know that 0.5 and 1/2 are equivalent, so we get the same answer just in a different format. I want this format because I want to link it to this this triangle in some sort of way. So I'm going to jot down on my paper what I just typed in. Sine of 30, this is understood degrees, even though I didn't type in a degree symbol, equals 1/2. Okay. Well, I notice on my triangle that I have a side that's 1 and a side that's 2. There has to be a connection. I just haven't figured out what it is yet. Okay, let's try another one. I'm going to go back to the trig key. And this time I'm going to try the second option, COS, which is the abbreviation for cosine. And we'll spell those out in the notes in a few minutes. And I click on that and I put in 30 and I get square root of 3 over 2. Now, if you're using your calculator at home, it's going to give you a decimal approximation. Something fairly ugly, probably 0.8660, something like that. This is the version I want us to look at because there's a correlation between this and what we're seeing in the picture of the triangle. So square root of 3 over 2 is the cosine of 30. All right, let's do one more. Trig, tan is short for tangent. We'll spell that out in the notes, of 30. Oh, that's kind of ugly. Let me do something different. Tangent of 60. I like that better. Square root of 3. Tangent of 60 degrees is square root of 3. Now, technically, it's over an understood 1. And I'm going to write that down because I need to see that. So I'm going to just use this as a jumping off point to attach these three functions to this triangle. It turns out that these are ratios of sides. The 1, with respect to a 30-degree angle up here at the top, 1 is the opposite side. So that means the 1 was the length of the opposite side from the angle. The 2 is the hypotenuse. So the sine of 30 degrees is the ratio of the opposite side to the hypotenuse for the 30-degree angle. It's a ratio of two sides. The calculator knows it's a ratio, and it's programmed to tell me what that ratio is if I know the angle. Okay, cosine of 30, well, square root of 3 with respect to 30 degrees is this leg over here. We call that the adjacent leg because it's next door to the angle. It's different than the hypotenuse. It is a leg. So this is the adjacent leg, the next door neighbor leg. And then 2, the bottom number, is the hypotenuse. Hypotenuse of the triangle. Tangent, well, let's see what this one is. 60 degrees. So I'm going to use this angle as reference. With respect to 60 degrees, radical 3 is the opposite side across from, and 1 is the attached leg, or we call it the adjacent leg. What we have here is all the possible combinations of ratios of sides. We can see a combination of 1 and 2. We can see a combination of radical 3 and 2. And we can see a combination of radical 3 and 1. So we have all the possible combinations of any two sides. Now the significance of that's not going to be obvious until after spring break when we actually use these to solve for missing parts. We're not going to do that yet today. For today, our goal is to learn how to write these ratios. Okay? Let's springboard to a different triangle. The 45, 45, 90 triangle has ratios 1 to 1 to square root of 2. The sine of 45 degrees, if I pick either of these 45-degree angles, is, well, let's see, sine is opposite over hypotenuse. Okay, pick a side opposite 45. 1. Hypotenuse goes on the bottom. That's the square root of 2. Now, if I rationalize the denominator of this one, because the calculator is going to automatically rationalize the denominator, I'm going to end up with square root of 2 over 2. So I'm going to go through that fairly quickly, but I want to show you the connection between that and what the calculator does. So if I go back to my calculator and I ask it for the sine of 45 degrees, it's going to give me square root of 2 over 2. It's going to give me that same answer. So the calculator actually knows to find a particular ratio of two particular sides and then give me the simplified form of that. Now your calculator will give you a decimal approximation. On this one, it's going to spit out an approximation that looks something like 0.7071. In order to get the ratio that doesn't have decimal approximations, we would have to actually get a picture and do it. Okay, so big idea. These three trigonometric functions, or trig functions for short, They take an angle of a triangle and report a pair of sides in ratio form. Okay, now let's go to the notes and let's summarize that. So back here to the notes. On the second slide of these section 3 notes, we have the formal definitions of the trigonometric functions, or trig functions for short, and they're used as formulas to find missing measures of triangles. We're not going to do that just yet. For now, we're just going to take a look at the definitions themselves. Well, let's write some longer words first of all. This first one, SIN, is short for the word sine, so that's the sine function. COS is short for the word cosine, that's the cosine function. And TAN is short for tangent. Now, you should be taking notes at this point. Everything else is just an introduction. Time for serious notes now. And notice on paper we don't put our angle A in parentheses. The calculator will always make us put parentheses around our angle. We simply don't write it down on paper because it looks a little cleaner. But there are understood parentheses around the angles that we just don't usually bother to draw. Okay, you'll recognize some of this notation. Sine was opposite over hypotenuse. That's the same thing that we saw back here. And cosine was the adjacent leg over the hypotenuse. And tangent was the opposite over the adjacent. So in terms of a general triangle, let's draw a picture. Leave some space over here for an example. Okay, let's draw ourselves a triangle. Let's make this one a little more generic. So there's a right triangle. We're going to call this triangle A, B, C. The only thing challenging about writing a trig ratio is nailing down which sides are which. The very first thing that I would do before I evaluated any trig ratio is I would nail down where my legs are. So the two legs, just like we did with Pythagorean theorem, the two legs make the right angle. So the two legs are AC and BC. That means the hypotenuse is AB. Hypotenuse is opposite the right angle. So I'm going to label the hypotenuse. I want to nail down the hypotenuse first. Make sure you know which side it is. Sometimes, depending on the orientation of your picture, sometimes the hypotenuse is harder to identify than other times. Of the two remaining legs, one is the opposite leg and one is the adjacent leg. And which is entirely dependent upon the angle that you're using for reference. If I were using angle B for reference, that's this angle in the bottom left right-hand corner. If I use angle B for reference, then the opposite side would be over here, side AC. It's across the triangle from B. And this bottom side, we would call that the adjacent leg because it's attached to angle B. In our formulas, we're going to reference an angle labeled A. So A is an angle. Capital letters are always for angles. So our angle of reference is this top angle up here. So I'm using this angle right here as my reference. Everything is done with respect to that angle. Sometimes we have a measure for it. Excuse me. As we did in the problems we did before we started notes. Sometimes it just has the name A, or B or C or Q or X or W or Y, whatever it happens to be named. So we're going to use A for reference. With respect to angle A, this red angle right here, across the triangle from it, so go to the opposite side, that's the bottom side, that's the opposite side of the triangle. And then the adjacent leg would be the leg that's attached to angle A. So that's this leg over here on the left. So I'm going to refer to that as the adjacent, and I always know that it's going to be a leg. Different from a hypotenuse. Hypotenuse is not a leg. We never call that the adjacent leg. Depending on how we turn this triangle around. Sometimes the opposites and adjacents change to different positions. It just depends on the orientation of your picture. Okay, now let's do an example. Okay, let's do a specific triangle that we don't actually know the angle measures for. So let's draw a right triangle. Let's call it triangle X, Y, Z. Okay, I want to find sine of X. Okay, so I look over here at my definition. Sine of X is the opposite over the hypotenuse. Now the hypotenuse is always the hypotenuse. It's really, really easy to nail down. If the legs are the top and right sides, then the hypotenuse must be XY. So this side is always the hypotenuse. Now the other two sides, whether they're adjacent or opposite, depends on the angle that you're referencing. So if I'm using X as a reference angle, then everything is done with respect to X. And with respect to X, I know that ZY is going to be the opposite side. Oh, you know what I forgot? I forgot to put some numbers on it. So let's get some numbers. Let's say that XZ is 12 inches, that ZY is 5 inches. That means the hypotenuse must be 13 inches because 5, 12, 13 is a Pythagorean triple. Now I have the side measures. I can actually calculate the sine of X. I can't use a calculator for this one because I don't know what the angle is. The calculator will only do trig if we know the angle. So I have to use the triangle. I do know that sine is opposite over hypotenuse. So I'm going to just write an abbreviation here. Opposite over hypotenuse, O over H. So I'm going to find opposite of angle X. So angle X is here. The opposite side would be across from, that's the 5-inch side. So I'm just going to put a 5 there because inches are going to cancel anyway. Over the hypotenuse, which is 13. I'm finished. All I have to do is write a ratio. Okay, let's find cosine of angle X. Okay, cosine is adjacent over hypotenuse. Adjacent over hypotenuse. Alright, hypotenuse is easy. I know it's 13 already. I'm going to fill that one in first. Now, the adjacent leg depends on the angle. I'm using angle X. So the adjacent leg is the leg, not a hypotenuse. It's the leg that's attached to X. So follow X out this way. This is the leg we need. It's 12. So the cosine of X is 12 over 13. We're finished. All we're doing is writing a ratio. Let's do a couple more. Let's do tangent of angle X. Okay, tangent is opposite over adjacent. O over A. Okay, opposite is from X. Opposite is 5. Adjacent is the attached leg, so from X the attached leg is 12. So 5 over 12. All we're doing is writing ratios. Let's do a couple with angle Y. So how about we do sine of angle Y. So if I change my angle, it changes the opposites and the adjacents. Hypotenuse is always the hypotenuse. I know that sine is opposite over hypotenuse, O over H. Okay, with respect to Y, this angle here, the opposite leg, so go through the middle of the triangle to the side opposite. That's this one here at 12. And then the hypotenuse is still 13. That one I can always just have labeled. Alright, let's skip to the tangent of Y. Tangent is opposite over adjacent. Opposite over adjacent. Alright, Y is here. Opposite is go across the middle of the triangle to the opposite side, that's 12. The adjacent leg is attached to y. So start at y. You don't want the hypotenuse, you want a leg. So look for the attached leg. This is the attached leg of 5. Finished. So all we are doing is writing ratios. And that's all we need to learn for today. So let's finish this up by taking a quick look at today's homework. Today's work is in your packet, pages 12 and 13, which is the first half of the worksheet. We'll finish it up on Friday. Get a little extra practice. So I'm going to skip to the actual picture of the worksheet, and it's just a writing trig ratios worksheet. So on this particular worksheet, you're just doing one problem at a time, one ratio at a time, instead of doing a whole list of them. So we'll do a couple of them together, and then I'll leave the rest for you to do. And I'm going to grab my sheet of white paper so that I'm not making a mess here. Okay, so I want to find the sine of A. Okay, I know that sine is opposite over hypotenuse. Okay, so I've got to find the opposite side of angle A. So angle A is here in the bottom left corner. If I go through the center of the triangle toward the opposite side, 40 is the opposite side. So 40 is my top number over the hypotenuse. Okay, the right angle's here. That means 9 and 40 are the legs. So 41 is the hypotenuse. Hypotenuse of 41. And that's my answer. It is that simple. You're just writing a ratio. Let's skip to one additional problem. How about a tangent problem? How about number 4? So for number 4, we want to find the tangent of z. So I look at my definition of tangent in the notes, and it's opposite over adjacent leg for angle z. So I need to see first of all, the side opposite z. Z is down here in the left corner. Go through the center of the triangle to the opposite side, that's 24. And the adjacent leg, so we go back to z, and we find the leg that's attached. The 26 is a hypotenuse. We don't want that one. We want the leg, the shorter of the two. So that's 10 is attached to z. 10 is your bottom number. If your fraction will simplify, and this one will, you should simplify your fraction. You can use a calculator to simplify it, or you can simplify it by hand. 24 and 10 are both divisible by 2. 24 will divide by 2 12 times. 10 will divide by 2 5 times. And so our final result is 12 over 5. That's all you have to have written down. There's not really any work to do other than if you have to simplify the fraction. You're just writing ratios. So for today, you're going to finish pages 12 and 13. Tomorrow you'll do pages 14 and 15 for extra practice. There will be one quick video tomorrow to show you once again how to use the calculator and how to round appropriately. Other than that, maybe a 5-minute video at most. It'll be super quick. And then we'll have a nice little break for spring break next week, which I'm sure we all could use. All right, do some practice and have a good day.